Hello, hi viewers and students. Very good morning to one and all. So in the last class, we were seeing that types of governors. So there are few types of governors are there: general type governor, potar governor, proyal governor. Likewise, different types of governors are there. So in the last class, we were seeing that white governor, which is called as a simple governor, and also that we have seen that potar governor. So Potar governor and the derivation of Potar governor, and finally after taking of a derivation, we have seen that a formula for Potar governor, how to calculate a height for Potar governor. So likewise we seen that a general formula. So once again I'll take you that Potar governor. This is a Potar governor. Here you can see that Potar governor. So the recognition of Potar governor, the identification of Potar governor is load is acting at centrally. Load is acting at central. So which representation is saying that it is a kind of Potar governor, and also that the kind of governor is having arms and links. So arms are upward up, links are down, and it is connected to the sleeve, right? And ball weights also is considered here. So the 2D diagram is representing beside of this. So this is called as a b is nothing but ball weight is acting toward downward direction, and ball is producing centrifugal force outwards. So fc is also is there. So ball is hanging with arms and links. So arms is producing tension, and links also producing tensions. So alpha and beta with angles of arms and links are producing tensions here. So that also is shown in the diagram. So this is what the derivation from this. So finally the derivation have brought this. So that also I taken in the last class how the derivation is taking. This is the final derivation, you can see here, final derivation. So speed square is equal to m plus m by 2, capital say m by 2 into 1 plus q by m into g by h, right? So this is also would be written like this: m plus m by 2 into 1 plus q by m into 895 by h. So where q is equal tan alpha by tan beta. So when tan alpha is equal tan beta, both are equal, then the time is which is equal to 1. So substituting 1 in a small q, then the formula would be become like this: m plus m by m into 895 by h. This is the final formula. This formula has to remember. This formula is considered without q. That means that tan alpha is equal tan beta. If not, tan alpha is equal to tan beta means that both are varying. Then we have to use this formula. If both are equal, then we have to use formula. Sometimes there is a friction force has to consider. Friction force has to consider with varying of the alphas, with varying of angles, then we have to use this formula. So friction force is considering when the two angles are equal, then we have to use this formula. So these formulas is these two formulas is one consideration without q. That means that both are equal. These two formulas are both are varying, angles are varying, right? So that is what we have to remember like this. Next to come to the problems. So a first problem under the Potar governor. So here the problem is a Potar governor has equal arms of each 250 mm long, each 250 mm long, equal arms of 250 mm long, and pivoted on the axis of rotation. Each ball has a mass of 5 kgs. This is mass of 5 kgs, and mass of central load is sleeve is 25 kgs. This is the 25 kgs. That means that big load is 25, which is placed at central, This is the 25 kgs, and this is the ball which is having a 5 kgs, right? And both are and both axis of rotation, both are equal arms, both are equal arms. Then the radius of rotation of the ball is 150 mm. This radius of rotation of the ball is 150 mm, And when the governor being to lift to 200 mm, because when the governor being lifted, the radius would be increases. It has been 200. When the governor is maximum speed, when the governor has been reached the maximum speed, the radius is varying. The radius is 200 from 150. 200 from 150. 150 is minimum, 200 is maximum. Find the maximum and minimum speed ranges of the governors. So N1 and N2 has to calculate here. So this is the general governor, Potar governor, and 3D diagram. So there are the arms and links. These two are equal. 250 mm, 250, 250, 250 always. Arms and links are both are equal. And when the governor is at initially it was if 150 mm radius, then after raising of this 200 mm, so centrifugal force is also varying. Next, come to this. So very initially, this is the diagram where we have to calculate first H1 and H2. Once we know the H1 and H2, we can substitute in the formula. Then we can find out the speed square. So here we have to calculate the minimum and maximum speeds and range of the speed. So this is the general formula here. General formula here. Angles are considering both are equal. That means that tan tan alpha is equal to tan beta. We are considering, because in the problem is not mentioned what is alpha and what is beta, not mentioned alpha and beta. That is why we are considering both are equal, which is equal to 1. So right, tan alpha by tan beta, tan beta, which is equal to q, which is called as a 1, right? So that time the formula would be like this. So mass, ball mass plus load mass by ball mass into 895 by h1. So here what to doesn't know, ball mass we know, central load we know, and ball mass also we know, but h is not given. H has to calculate here. This is the height total has to calculate. But taking of a trigonometry equation, Pythagoras, by taking of a Pythagoras equation, then we can calculate the h1, right? H1 is equal to what? Pg is equal to H1 is equal to Pg is equal to under root of BB square plus BG square. BG square minus BG square. Then we can take this. And finally, the height is 0.2 meters. 0.2 meters. So that value is substituting over here. Then this is the speed over. Then similarly, calculate H2 by taking of a Pythagoras principle, right? So after taking up this 0.15 mm, so m plus m by m into 895 by h2. So h2 value is substituting here. H2 value is substituting here 0.15. Then finally this is the speed. So N1 is this one, N2 is this one, then N2 minus N1. This is the speed variation 20.7 RPM. 20.7 RPM. So very simple is here. If in the problem is mentioned that what is alpha, what is beta, both are varying or both are equal, then we have to find out that from the problem. If not is given, both are not given, and you have to consider that both are equal. If specifically is mentioning that from the problem, then we have to go according to that, right? But this formula has to remember caps m, small m plus caps m by small m into 895 by h1. N1 square is equal to, then after that both are equal. Come to second problem. This is the second problem. So the arm of Potar governor are each 250 mm long, each 250 mm long and pivoted on the governor axis. The mass of each ball is 5 kgs and mass of central sleeve is 30 kgs. Sleeve is 30 kgs. The radius of rotation of the ball is 150 mm. When the sleeve being raised and reaches the value of 200 maximum speed, then determine the speed ranges of the governor if the friction of at the sleeve is equivalent to F. But in this problem, friction as given. So we'll see how the friction is considering. How to calculate the problems when the friction is mentioned in the problem. Determine how to speed ranges is modified. N1 minus N2 has to calculate here. So as like similar problem, H1, H2 has to calculate. This one is the H1. This one is the H1. This one is the H2. And these are given that, and but alpha is equal to beta here, not mentioned that, but forces has given, for not force, friction has given, friction has given 20 newtons. Friction has given 20 newtons that we have to take here. Friction has given that we have to calculate here, right? So H1, calculate the H1 first. H1 is equal to Pg by taking of a Pythagoras, by taking of a Pythagoras equation. So calculate H1. So H1 is equal to this minus this. So PB square minus BG square, 250 minus 250 square minus 150 square. So it is a 200 mm by taking of a calculator. So this is 0.2 meters. After calculating of height for minimum speed, then substitute in that n1 square is equal to m plus m by m into 895 by h1 square. So h is nothing but 0.2. Substituting of the value, this is the speed of this minimum speed. Then come to that similar way, h2, calculate the h2 value. H2 is equal to, by taking of a Pythagoras equation, 250 square minus 200 square, 0.15. Then this is the n2 speed, maximum speed. So this is most important, minimum speed, and this one is the maximum speed, right? Maximum speed. Then go for ranges. When taking of the ranges, this is the ranges, n1 minus n2 minus n1, because it is a maximum, it is a minimum. So this is the speed, 274 rpm, 274 rpm. If friction is considered, this is the formula. So when friction is considered, the formula is varying. Gravity is considering mg, caps mg plus small mg by small mg minus f by mg into 895 by 895 by h. So here 1 plus minus friction, 1 plus friction. So minus is indicating that when the sleeve moves upward direction, plus indicating that when the sleeve moves downward direction. When the sleeve moves downward direction. And some textbooks are considering minus is indicating when the moves upward direction, minus plus is indicating that when moves downward direction, right? So anyway you can take that, but it depend on the textbooks, we are following that also. So m we know, this also we know, F also we know from the problem, 20 is given, H also we know, 0.2 for minimum case, for maximum case also we know. So after substituting of all the values, this is the value of N1, minimum value of minimum speed rate, minimum speed with respect to that radius. Then come to for maximum speed, then this is by using of this same formula, mg plus m into g plus f by mg into 895 by h2. So h2 we have calculated already previous slide. Then f also given, but we are taking plus here, downward upward direction. And after doing of this all values, substituting of in this formula and doing of that, so n2 is equal to 10. So n2 minus n1 is equal, this is the ranges of the speed, ranges of the speed. Very simple here, but formula has to define here. So once you know the formula, you can substitute the formula and you can find this. In this case, you just come to this alpha and beta, both are varying here, not constant. Alpha 1 is given in this problem, alpha 1 is given, alpha 2 is also given, but alpha 1 and alpha 2 both are varying, right? For this case 30, for this case 40. Then in this case you can see that very simple here. You can see that h1 is not given, so h1 also you can take by using of a Pythagoras, right? But very thing is h1 is equal to pb, h1 is equal to pb. So pb cos 30 here, h1 is equal to pb cos 30. So like that you can calculate pb. So this is the formula. This formula you have to substitute. friction has to consider here, and q also tan alpha by tan beta, that also you have to calculate. So after knowing of that all values, you can substitute this formula and you can find out this n1. So h2 also you can calculate by using of a Pythagoras, and calculate the q2 tan beta by tan alpha. Then this is the value, that value substitute in this formula, then you can know the n2 value. So after that, the difference n2 minus n1, right? Likewise you can calculate. So this problem is totally different from compared to previous problems. But previously this p and d are both mounting on same axis. You can see here p and d are mounting on same axis, but here it is it is from some distance. It is from distance, right? P is acting at one axis, d is acting at one axis. So p to d is difference is 30. P to d is difference is 30. So according to that, the formula is also derived, the same formula. So n1 and n2, you can calculate the values, all values, and substitute these values, right? So this is also q2 value. So after doing of this, substitute in these values, so you can get the n1 minus n2. This is what the problems is deriving like this, right? So but the thing is, you have to understand the problem. So what has given, how this has given, so how to use the Pythagoras. So sometimes radius also will give, height also will give. Then one side of the Pythagoras is not giving, then that you have to calculate. So we, by using of a Pythagoras principle, and use the formula speed, minimum speed and maximum speed formulas, just substitute the values in that, and finally calculate that. Okay, guys. This is what about Potter governor with problems, formula derivation and with problems. So next class I'll go through the to Proel governor. Potter governor is completed. Next to Proel governor, I'll take you that. Okay. Have a nice day. Thank you one and all joining with me. Next class I'll continue Potter governor. Okay. Bye.